The sharing, can you please allow me to share my screen?
Please, sir.
Bismillahirrahmanirrahim. Can you please see my screen?
Yes, sir, we are seeing.
And I'm audible to everyone.
Yes, sir, it's all clear.
Right. So, Bismillahirrahmanirrahim. Thank you so much, dear student. We are here for our second lecture of this workshop. And today we will have discussion about supervised learning in machine learning. Just to remind you, the last lecture a little bit, we have some discussion about data science, then the importance of data science, and then onward, some intro about machine learning, that how it can change the human life. Later on, we also had some discussion about application of machine learning, and then a few success stories and a few failures as well. And the same pattern will also be followed in today's lecture. Today I will be a bit fast because we also have the lab session in today's lecture. Besides that, there are a few videos, a few case studies, a few research papers, and the links are already pasted on the slides. So if we couldn't get time to show you all those videos or to discuss those research articles or the latest review or the case study related to that, so you may later on look into all those things, so the things might be more clear to you. So starting today's lecture from here, I am Dr. Muazzam, as you know well from the last lecture. And the most important thing which we mostly imagine that what will happen in future. And if you look at this first slide, how the world do we want in 2030? What are our expectations and what our actions are? So there is a bit prediction based on your action and based on your personal wish or personal desires. So there might be some gaps. If you desire something or you wish something that might happen, or it should be the final outcome of any action that you are performing today, so you should tell your action accordingly. You should move in that particular direction. Sometime you might know about this very famous quote that speed is not important. Our speed is not always important, but direction is. So Martin Luther King said that if you want to fly, fly. If you can't fly, then run. If you can't run, then walk. If you can't walk, then crawl. But on each and every second, you must move forward in the right direction. So that's why direction is very important. And same is the topic in our today's lecture. So here is the agenda for today's lecture. We will discuss about a little bit about supervised learning, then types, then a case study, then regression and classification algorithms are techniques that are used for supervised learning. So here you can see the supervised learning is actually an activity that is fully supervised by someone, by some external entity, in which we mostly focused on labeled data and then onward help the machine learning model to learn. So once the machine learning, can you please keep quiet?
Sir, I just
Ishaq Ehsan Tariq, please. Yes. Can you please try to mute her mic?
yes, sir. I muted this. Please carry on.
Thank you. Thank you. it actually uses the label data and go to the final results. You can see here in this diagram, we have apples, and the model, that machine learning model exists here, don't know about that, what kind of fruit it is. And then we can provide this information that this is apple, and then onward, later on, when we give or show apple or this image to this model, then it easily understand based on the knowledge it gained from supervisor, or the help it get from the supervisor. It exactly or accurately find out that which fruit it is. You can see here at the bottom, we also have a video that will further explain that how supervised learning takes place and how we train our model. So I'll request you to kindly watch this video as well. Here is the complete detail of this supervised learning, and you can see that we have raw data from input side, and we have different shapes given here. Some are triangle, cubes, circles, and so on. And then with the help of a supervisor, we actually train our model and let it know that what this sample is. Either it's a circle, either it's a cube, either it's a triangle, and so on. And after this learning, with the help of a supervisor, the system is able to categorize and do the further necessary processing to separate these different different samples, are different types of images that we have. So here you can see that the output, we have circles, we have cubes, and we have triangles, these shapes in separate form, and it very accurately categorize and put them in a singular or in a single or separate place together, which are which resemble with one another. Here are some application of survived learning, supervised learning. You can see here that one of the most important thing is predicting the housing prices. You know about Islamabad that there are some very huge spikes in the prices of houses. And even in certain situations, the AI models failed in this prediction process, because the prediction is lower, but the house's prices actually goes more up than the expected values. So predicting housing prices, you can see the text categorization. You can also see here as well in the diagram that we have different types of text messages or email we received, and then we categorize them. Either it's a spam or it's a actual message from an authentic user. Then face recognition is one of the very important characteristic or application of this tech. You can see we have two phases. One is face detection, that first it detects the face. Might be there's one human face, then another face is of some animal, then might be some other images that might be in the circular shape, which have some resemblance with the human face. And the next activity is that based on the intelligence, it can recognize the face as well. So there is some work still going on just to improve the accuracy and to improve the efficiency and precision of such models. Next one is signature recognition, and that is very important in today's digital world, that how you can recognize then the customer discovery, spam mail detection, weather forecasting, and then just like prices of housing, how the stock prices will move up or will move down. So this is the very important prediction algorithm, which is very helpful to decide the future action Either you want to buy the shares from any company, you want to buy a house, or you want to buy anything, then it is very important to know what are the market trends and which step or which action might be more fruitful or more beneficial for you. Now, there are two types of supervised learning. One is regression and the other one is classification. Now onward, we will discuss both of these techniques are the way to resolve issue are to learn things in detail. So here you can see we have a regression on the right side and we have classification on the left side. In regression, we have different techniques that include regression tree, Bayesian model, and regression analysis. While on classification side, we have support vector machine, random forest, k nearest neighbor, and decision tree. We actually prefer these algorithms in certain scenario, and that will be the focus, that which algorithm or which model or which technique we should prefer in which scenario. Here you can see the comparison between regression and classification. Both activities are related to the weather. If you have a look to the regression side, then the focus is that what will be the temperature tomorrow. So that is the prediction that what will be the temperature tomorrow. If it's a cloudy weather, if it's a clear weather, if there is raining, if there is snowfall, then what is the maximum and what is the minimum temperature tomorrow, and what will be the average in between. Then onward toward classification, you can see that we actually know about what will it be hot or cold tomorrow. And based on this regression, once we predicted the temperature, then we can easily classify or categorize that which time slot will be the hottest one, which hour or which second or which minute or which time span will be the hottest one, and which one will be the coldest one, and what will be the normal temperature. So look at this, we have to decide between two peaks, the lowest and the highest, and then onward the normal one. So we can decide in this classification that how we can handle different kind of activities in that. Here is the regression algorithm, and you can see here that regression is actually about the prediction of future. The future values are predicted with the help of this algorithm, and the input for this algorithm is your historical data. And based on that, we actually look into the trends, the trends of data, and give some prediction about the future. In many situations where the occurrence of an event or the data generation is not random, it's in the same sequence, then we might predict the future very rightly. But for example, there is more randomness, there is no sequence, and anything may happen, then it is very difficult to predict what will happen in future. For example, if you look into your education system, if you want to study from where you will start, then where after promotion, where you will move on, and then you have to decide the track. If you are moving toward the medical side, then at the end you may become a doctor. If you are going toward engineering side, then you will become an engineer. And if you are going toward the other competitive exam side, so you might have some position in the bureaucracy. But if you, it's illogical that you choose to select the medical field and you expect that the person will become an engineer. If someone choose the engineering field and you predict that he will become a doctor, so Einstein quote is that giving the same input again and again and expecting a different output is nothing but just stupidity. So this input is totally based on the historical data, based on the previous information, and then look into the previous data or history. We predict the final actions, or we predict the next step as well. So here you can see we have relationship between dependable and independent variables. So dependent and independent variables may have some sort of relationship with one another. Sometime it might be inverse, and sometime it might be direct relationship. We can take the example of a company. For example, if you are hired as a manager of some company, and they give you a task that you can predict the future outcome or the future budgetary allocation for this company. So first you have to look into the previous budget that was allocated, where the budget was less, where it was less, where it was fully consumed, where they have extra allocation, and so on. And based on that, you can look into the future prediction for budget of that particular organization. So there is a relationship between both entities, that the budget you decided and the variables which can play a major role in your budget allocation, from where you have to cut it down and from where you might increase. So here in this diagram, you can see the prediction analysis with the help of regression. We provide data, input X, and here are certain features that we derive from this data. And that's what I told you, the trends and data which exist and which might be helpful to know about. And then onward, you actually learn that in which direction, if you take this section, if we increase the budget here and decrease here, then what will be the impact on the final outcome? And then onward, you predict the final outcomes. We also have a video, a YouTube video, and as well as we also have a case study here for the regression analysis. And I will recommend you, if you look into this later on as well. So it will be very helpful for you, that you can know much more about this regression algorithm. Here are some types of regression, and you can see that the most famous or the most common regression algorithms are linear and logistic. And we also have some other types that might be used in some scenario where it is required. Here is the application. Look at this for the future prediction of regression. And you can see this research article, which was published just 1.5 years earlier, predictive analytics of machine failure using linear regression on Chemi platform. One of my PhD student, is also working on this predictive analysis of industrial Internet of Things and edge computing, that how we can predict the failure of a machine or a node or a computer earlier before it fails. And before its failure, we actually take the necessary action and replace that particular component or that particular equipment as well. Regarding this future prediction, I have also posted these 3 more links, and I will recommend that you should study all these 3 links, so you can have more idea that how successfully the prediction has been done, and how a big destruction, disaster, or financial damage has been addressed earlier. and how the prediction became more helpful to the organization by taking certain action before going into that disaster. And that is actually the vision we are looking for our future industry and for our future communication models as well. Here is another one, machine learning application and failure prediction. And you can see that how efficiently, this is again another article. And with this report, you can check that with this report, you will find out each and every algorithm where it fails. So if I might be able to give you an assignment, then it will be that look into those applications or those approaches where these algorithms are performing best and where they are poor, where they fail. So with this kind of analysis, you will understand that in which scenario, where which algorithms or which technique we can preferably use. Here are some stories of AI and machine learning failure, stories of AI failure, and how to avoid similar AI failures. You know about that the new iPhones or some other new mobile phones actually use a facial recognition, and they failed. With the help of 3D printer, they actually developed their face, and then the system or the app was deceived with the help of these 3D models. I would like to show you this video. If you allow me, then I will show you this video that how it actually fails. Can you see my screen?
Yes, sir.
Okay. So look at this 3D printed heads actually failed the cell.
Somewhere at some point in time when you're out and about. But rather than kill your privacy, facial recognition on smartphones is supposed to protect your digital life. We decided to test that theory by looking at the security of various Android and iPhone facial recognition systems. And we did this with a 3D printed head, seeing which phones would open when being presented with the fake. The first stop was Backface in Birmingham, UK. It's a small company founded by Tim Millward that makes 3D printed models for all manner of customers, from filmmakers to government suppliers. Tim, can you tell us what we're actually looking at?
Well, this is our 3D scanning rig. It consists of 96 DSLR cameras, which all fire at the same time, and that captures all the data that we can then use to produce a 3D scan. So we're gonna pop you in here, we're gonna process all that data, and then we'll produce a 3D printed head.
Backface then constructs the model with a 3D printer that builds up layers of powdered British gypsum. Then some final colourings are added and the life-size head is ready within a few days, all for just over 300 quid. For our tests, I used my own real-life head to register for facial recognition systems across 5 phones: an iPhone 10, an LG G7 Link, a Samsung S9, a Samsung Note 8, and a OnePlus 6. We would then see whether the devices would let us in with the fake head. Okay, so this is the 1+6, pretty much opens as soon as you put your face to it. So that's open straight away. Try it with the face. Open straight away. It's the worst. So this is the Samsung S9 with bright white light, which sometimes works and sometimes doesn't. So I test it my own face now. Okay, I unlock that time. We try it with the head. It won't open there, won't open there. But if you find the right angle, it opens. For the Samsung phones, as with the LG device, it was possible to choose between either faster facial recognition or standard. The faster the recognition, the less secure. All right, this is the Samsung Note 8. This is actually not bad. Okay, so we turn faster recognition on. It recognizes my face, so faster recognition is just the weaker version of facial recognition. Let's see if the face works. Okay, so yeah, faster recognition on that one, at the right angle, opens it up. Okay, so we're now going to test on a softer, warmer light, because we think that it's going to work a little bit better. Now we're going to try it with the slightly harder facial recognition. It's a slower version of facial recognition, so it should be more secure. We'll try it with my normal face. Unlocks fairly quickly. So now try it with the fake head. And that's unlocked. So with the softer light, for some reason, the head seems to work even on the strongest facial recognition setting there. The LG device was, for the most part, impenetrable. Though in the right light and on a lower security setting, it was possible to break in on occasion. As for the iPhone, the fake couldn't find a way in. Apple's heavy investment in the security of Face ID really does seem to have paid off here.
I think if you have genuine concern about the possibility of somebody spoofing your biometric and unlocking your phone, I would say focus on the secret aspect, which is the PIN or the password, because the reality with any biometrics is that they can be copied. I guess anybody with enough time, resource, investment and objective will invest that time and resource to maybe try and spoof some of these biometric. So the best way to keep your data secure will be through the secrets, which only you will keep in your head.
So you have seen that how the AI by itself failed in many cases, and there are many other things, and that's why while preparing this lecture, I have passed through many information that specifically for your financial transaction, never use your facial ID. You must prefer your password, you must prefer some other secret codes and so on. Here is also on this slide, you can see there are some stories of AI failure and how you can avoid AI fails. So this is a complete article, and you must read it. Then you will understand that human's tell is much supreme from this AI and machine learning. And there are certain things where AI and machine learning couldn't meet the expectation where the human being stands. Here's the type of regression. We have linear regression analysis. The relationship in this, as we discussed earlier, between dependent and independent variables are drawn, and it mostly lies on a line. It actually predicts the value of a variable based on another variable, and as I told you, that it's like a chain, and the different parts of a chain are combined with one another, and if you open it down, then definitely the final analysis of your prediction may be wrong enough. Now here, the example we can use is the relationship between height versus weight. Yesterday, we had this discussion with one of my friend, and we discussed that either our weights are fine enough with respect to your height. Look at this. There's an age at which your height actually stopped, but your weight doesn't. And it depends on the consumption of your food and what kind of food you use or you utilize, then it helps to grow your weight. So what is the perfect weight with the perfect height, and how you can maintain this? And this is one of the important category of medical applications that is used, that what is your height and what should be your expected weight, and how much exercise or activity or physical activity you must have every day to maintain a good health. Then we have the nonlinear regression, and as you can see here in this diagram, it's not like linear on the straight line. It's totally a zigzag path, and that's actually the reason that the final outcome doesn't stand at the same level. There are certain independent, as we discussed, and dependent variables which can change the value abruptly, and even beyond your expectation, you are getting the final outcomes. So nonlinear regression is actually a model that provide again the relationship between dependent and independent variable, but unlike the linear one, the non-linear regression is used to predict some other activities, for example, population growth that may goes up and down. The recent incident in Turkey, as you know about, have taken place, and many thousands of people actually died because of that. So such natural disaster, and similarly the birth control system might not work, and therefore we have some sort of irregularities in the graph or in the pattern that we received as a final output. The next one, the next technique of machine learning is classification. Classification is actually categorizing things. You can see here on the slide that classification actually sort your data into specific categories using a label data set, and it weigh the input features so that the output separate one class into positive value and the other one into negative. The diagram actually shows that you have the vegetable and fruits and groceries together, and later on, with the help of classification, you categorize them, and you distinguish what are vegetable and place them in that class, and then similarly what are the items that belongs to groceries are put into another side. Now here is another kind of classification for our base. As you know that while you are using anything, either it's a food item, either it's something related to other activities, some part of that might go in your garbage box or in the waste box. So here you can see we have categorized the waste bin into two types, the recyclable waste and then non-recyclable. So the further categorization of that, either it's a glass, either it's a metal, it's e-waste like your computer, laptop, or other electronic gadgets, either it's organic, it's paper, or it's plastic. And this is actually the right way that you can put the waste in that particular box, and it's easy for the city administration to later on put them together and send them which are recyclable for further operation. Here is the detailed analysis of machine learning algorithms. As we discussed that we have supervised and unsupervised. Today we are focusing on supervised algorithms, and we have two types: regression that we discussed earlier with respect to linear and non-linear, and now we will discuss about classification and different algorithm used in classification. Here you can see a classification classification is further divided into three types. We have the binary classification, then we have multi-class classification, and we have multi-label classification. In binary, we have simply yes or no. Either the mail is correct or it's a spam one. In multi, we further move to detail about any entity, and in multi-label we further means move more dense to find out some more feature about that particular entity. We have 5 classification algorithms. You can see we have the logistic regression, Navy Bayes, k-nearest neighbor, decision tree, and support vector machine. We will later on discuss all these techniques one by one. But today we have a little bit discussion on the logistic regression. So here you can see, as we discussed earlier as well, about the same example of the weather, that logistic regression is used to calculate or predict the probability of a binary event occurrence. Either it's yes or no. You know about the quantum computing, where we have 0, 1 together. But in traditional computing, we have either 0 or 1. Either it's off or it's on. But in quantum, we have the qubits where you can possibly expect 0, 1 together. So to determine if a person is likely to be infected with COVID-19 or not. So first you have to look into the initial conditions or the input data, that what is the probability of a person to be affected by COVID-19. So it might, this determination might vary with respect to job nature as well. For example, if you are a doctor, if you are a nurse, if you are someone who is working in any hospital or any clinic, so it means you are more exposed to those patients. Or sometime might be you have a COVID patient, COVID-19 patient at your home, so still you are more exposed to that virus, though you are not working in any hospital. So it may vary from person to person, but some other people who are not too close to those patients, not working in hospitals, neither have a patient at home. So the probability to infect with COVID-19 might be less. So this is actually the way how you know that what is the probability. And for example, sometime, for example, if we are living in Islamabad and almost the population of city is 3 million, so if 0.1% or 1% people are infected, then we can predict that how fast this disease or this COVID-19 will grow in the city. Another example is here with the help of logistic regression model. You can predict the weather for tomorrow if you know about the temperature, humidity, and the wind. Then you can predict it, that what will be. And if you look into those models, it's very easy. We are almost at the verge of Ramzan, and we always have these fights that today we should have the first Ramzan, when we have to celebrate the Eid. With all these models, if you look into the movement of moon, sun, and earth, so you can easily predict when should be the first Ramzan, and when we should end it, and when we should have the Eid celebration, either the Fitr or Eid al-Adha, and so on. But unfortunately, we don't go for the scientific tech or these scientific way to resolve our small issues that unfortunately we are still engaged in, and you will see it just 2 weeks after this. Here are key advantages of logistic regression. You can see here that this is much easier to implement than other methods in machine learning. And that's what I told you, that you have to look for all algorithms, that which algorithm should be preferred in which scenario. It works well when the data set is linearly separable, and it also provides a valuable insight as well. Here is the difference between regression and classification. If you have a look for the regression algorithms, it is used to predict the continuous values such as price, such as salary, such as age. And salary, for example, if you are serving an organization, how much increase they have per year. For example, they give increase of 5%, 10%, that how much your salary will be after 20 years. For example, meanwhile, if there is a promotion criteria that after 5 years service, you will have to the next cadre, then after 10 years service, you will have to move to the next cadre, then all those calculation has been done. And same is the case with the age. While the classification algorithm are used to predict and classify the discrete values such as either it's a male or female, either it's true or false, either it's a correct email, spam or not spam, and so on. So there is, if you have a look to the differences, the one is classification is mostly binary kind, while the other one is, as we discussed in the non-linear regression, that it is mostly analog kind of signal, while the other one is totally different. So I have taken half of a time just to have more time for the practical work. And thank you so much for my side. It's almost 45 minutes that we have done. And I just skipped the videos, the case study, and the research articles, while the links are pasted there on the slide. And I'll request Mr. Omer to share it with you people, because just I have seen your messages in the chat that you didn't receive those things. I will also share these slides with Mr. Omer and you will further get it. Now I would like to request one of my student, Mr. Aklim, to kindly share his screen for the practical assignment, so you can have a look at how we can do this. We have prepared a few experiments as well, and you will let you know that which options do you have to practically or to implement it through certain programs. Aklim, are you there?
Yes, sir.
So I will stop sharing my screen, and next is I'll hand over to you. So you might please go ahead with. Omer, can you please make him the host as well?
Yes, please. So he can also share the screen. So
Right.
yeah.
So go ahead, Aklim.
Can you see my screen?
Yes, please.
Assalamu alaikum people, hope you are doing great. And purpose of this implementation is to show you the implementation work of machine learning algorithms, and specifically supervised machine learning algorithms, that how we will apply supervised machine learning algorithms based on given data set. So we are considering Google Colab to perform all of our work. So if you want to open Google Colab, then you will just write Google Colab on Google. And just go to the first website. And you will see interface like this. It will show you all the work, whatever you already have done. You can open Jupyter Notebook. Basically, it is providing you a Jupyter Notebook interface to perform our Python related tasks, our machine related work. So you can open any Jupyter Notebook file from Google Drive, or you can open from my computers. So you will just log in with your Gmail account, and it will show you interface like this. And you can open any Jupyter Notebook, whatever you are working on. So Jupyter notebook interface is same like this. Google Colab is basically an online platform given by the Google, which gives us free GPU support, RAM, CPU, ROM, and some kind of storage to perform our machine learning task or to perform any basically Python related work. So if we talk about little bit Google Colab, then you can open any file from here. You can create a new notebook. You can open from Google Drive, rename, save, download, and print in PDF form. So if you want to create any cell to run code, you will create on this code button and it will create a new cell and you can write Python code inside this cell. And if you want to give any heading, then you will click on text button and you can write any heading. You can insert images, bold, or you can give numbers. So whatever you want to write in this text box, you can write. So basically today we are focusing on traditional machine learning algorithm, that how we can apply traditional machine learning algorithms. And specifically today we are considering linear regression and logistic regression to perform a model training process and evaluating our model. So the procedure is same. You can follow this procedure to apply any traditional supervised machine learning algorithm, whatever you want. But specifically today we are focusing on linear regression. So if you want to run the cell, you will click on this button and it will execute your Python code. So in today implementation work, we are using 4 main libraries: pandas, numpy, sklearn, and matplotlib. If you want to work with the machine learning and specifically with Python work, then you must have to understand pandas, numpy, sk, and matplotlib. These are essential libraries if you want to work with Python to train your machine learning algorithms. So pandas is a Python library that we can use to read our data set or to write our data set from memory. And numpy is a Python library that we can use to perform mathematical operations. And sklearn is a Python library that we can use to extract built-in Python machine learning algorithm, traditional machine learning algorithm, for example, naive Bayes, decision tree, random forest, or any algorithm that you want to apply, you can use sklearn library to apply. But specifically in this case, I am using sklearn library to import linear regression model. And matplotlib is a Python library that is used to perform visualization related work, for example, drawing graphs. So I am importing these libraries, and if you want to run, you will click on run button and it will execute the Python code. So the next step is to import our dataset. So we are today considering 4 projects to understand linear regression and logistic regression. And the first one project is very simple. We have one dependent variable and one independent variable. And the first step is to import the dataset. So in Google Colab, you can import dataset in Google Colab with the help of Google Drive. So first step is to connect your Google Drive with the Google Colab. So you will click on this button, then it will mount your Google Drive into this Google Colab. And if you want any file from Google Drive, then you will have to give the path of that file. And in this case, my file name is home prices. So you will write /content/drive/my drive and the name of directory, whatever you have in your Google Drive, /name of the file dot extension of that file. So this is the first line is related to giving path of the file. And the next step is to read file from that path. So we are using pandas library that we already imported to read that CSV file, and you will call read CSV method to extract that file. So it will read CSV file from this path. So I'm running this cell. So this is a small version of our dataset that we are using in the first example. So we have area and price, 2 columns and 5 rows. So pandas is basically using or giving us data frame. Data frame is nothing but we can consider it as 2D array, or we can say it is a combination of rows and columns. So whatever you will read from any file, pandas library will convert that file into data frame to visualize that. So we are visualizing file in the form of panda data frame. So if we want to plot this data set on a scatter plot, then we can use matplotlib library by giving PLT. PLT is the dummy name of whatever we already imported. And then X label, giving X label area and price, and then scatter plot giving data set area and price, and color red and marker whatever you want to denote. And it will plot your data set. So in X-axis we have price and Y-axis we have area. So the problem that we are going to solve is predicting the house price based on given area. So we are considering linear regression algorithm. So in this case, area is our independent variable and price on Y-axis is a dependent variable. So the next step is to split the dependent variable and independent variable. And in this data set, we have only 2 columns, on one in which one is dependent variable and one is independent variable. And we are splitting price and storing in a new data frame. And rest of the area we have. And this is the price that we want to predict. So in price variable, we have target, price variable is target attribute, and new def is our feature, that is area. So the next step is to give this data to our model to perform prediction. So the next step is to build our linear regression model. So we are building linear regression model, and we imported this linear regression model from sklearn library on top. And reg is model that we build, and .fit method will start the process of model training, and .fit method will take 2 parameters. First one is the list of features, and the second one is our target variable. So new df is denoting to area, and price is our target variable. So just run it. So the model has been trained, and the next step is to perform prediction from our model. So we are giving 3,300 as area value, and we are asking from our model to predict the price of this house. So model is predicting 62, 87, 15 as price. So let's see how model is predicting this value. So as you know, linear regression is all about building a relationship between dependent variable and independent variable. So we gave area to the model, and model already learned M and B value. M is slope, this is the line, and B is intercept. In other words, M is weight and B is bias. And when model will take area, it will multiply with M and add B and predict the value of price. So if we want to see the value of B and M, we can get that value by running this code reg.intercept. So this is the value of B, reg coefficient, and this is the value of M. So let's understand how model predicted this value of price. So we gave 3300 and it multiply with 135 and add 800616, and then let's run it, and it is predicting the price value. So it is same whatever model already predicted. So you can match these values. So the same, this is how the model is predicting in specifically linear regression algorithm. So let's perform another prediction. We are giving 15,000 area and model is predicting the price. So if we want to generate, if we want to perform any other prediction, you can simply read file from Google Drive. So this is, I am reading file from Google Drive. It is another file that contains areas list, giving that file to the model to predict prices. And model is predicting prices by giving areas. And these are corresponding prices related to areas. And if we want to store all these results in a CSV file, then we can use a .csv method by giving name of the file to generate a new CSV file. So let's click on it. And then it generated a new file prediction. Let's open it. It will show you the work, whatever the model predicted. So this is the area and corresponding their prices. So this is how model model was predicting. So we take only one dependent variable and one independent variable. Let's consider another example where we have more than one independent variable and then corresponding their one target variable. So let's consider another example. We are importing related pandas, matplotlib, sklearn. Let's talk about cburn later on. So we are importing these related libraries, reading car dataset from Google Colab. So the next problem is we want to predict the price of used car based on their features. So in this dataset, we have total 9 columns. One selling price is our target attribute, in this case dependent variable, and rest of the 8 are features, or we can say independent variables, and the model will predict selling price based on these 8 features. So let's check. DF is basically a data frame that we discussed earlier, and we are calling is null variable and that dot sum, and we are just checking that whether we have any null value in our data set or not. So if we have any null value, then we must remove that record. But in this case, we don't have any null value. And df.describe, describe is a Python, is a pandas method that will give you a brief statistical overview of your data set. For example, how many records you have in each column, mean, standard deviation, mean, 25%, 50%, 50%, 75%, and the maximum value, whatever you have in the specified columns. And if you want to get what are columns in your data set, then you can use this method dot columns. It is pandas method, pandas attribute that will give you list of all the columns, whatever you have in your data set. And if you want to count how many values in each column you have, you can use this method data frame by giving column name as index dot value count is a method, and it will count all the values whatever you have in that columns. For example, in fuel type column, we have petrol, diesel, and CNG, and it is counting, giving frequency of those values. And same like if you want to store or if you want to get any column from the data set, then you can use this method data frame and giving name of the column as input, and it will extract that column, and you can store that column in another variable. So if you want to check how many rows and columns you have in your data set, what is the shape of your data set, then you can call df.shape, and it will show you that we have 301 records and 9 columns in our this particular data set. And if you want to replace any value with another value, then you can consider this method dot replace, giving that column name and giving corresponding value. So we are in this case basically encoding categorical values into a numeric value. And why we are doing this, it will increase the processing of our model training. And get dummy is same replace, so we can use either replace or get dummy. And then we are dropping car name and selling price, and then storing rest of the columns in X variable. Why we are doing this? Because X will denote all the features, or we can say independent variables. So car name is, we are dropping car name because car name is irrelevant feature in this case. So whatever feature irrelevant in your data set, then you can drop that feature. And we are dropping selling price because selling price is not a feature, it is our target variable, and we are storing that target variable in an other variable, and in this case that is y. So our data set is prepared, and the next step in machine learning is to split our data set in two, or we can say three parts. If we talk about two parts, then we can divide our data set into training and testing. And if we consider three parts, then we can also divide our data set into training, testing, and validation. But in this case, we are dividing data set into two parts, training and testing. So train test split is a method that we imported from sklearn library, and it will split our data set into two halves, training set and testing set. So test size will in test size it will we are considering 0.3. It's mean we have 30% training set and 30% test set and 70% training set. So X test, X train, X test is denoting to the features. Y train is denoting to the Y trains corresponding target values, and Y test is corresponding test data target values. The next step is to train our model. So we are building linear regression model and calling .fit method on that model and passing xtrain and ytrain as training dataset. Xtrain contains independent variable features, and ytrain is our dependent variable. In this case, that is selling price. And the next in the next step, we are giving X test and Y test to check the performance of our variable. So let's run it. So it is giving 57% accuracy. That is not good, but the purpose of this work is to show you how we are training linear regression model. So we consider two examples, one dependent variable and independent variable. And in other example, we have considered 8 independent variable and 1 dependent variable that was selling price to predict the value of price based on 8 features of the car. So now let's consider logistic regression. So logistic regression is same as linear regression, but the difference is logistic regression is following the process of regression to solve classification problems. So in linear regression, the outcome was a continuous value, a fuzzy value. But in case of logistic regression, it will give us a categorical value, or we can say a crisp value. So in this case, we are considering library cburn, pandas, numpy. Cburn is another visualization library that we can use as an alternative of matplotlib library. It is advanced form of matplotlib library. So I am just showing you variation of different libraries. So Seabird library is also giving us some kind of a data set to show you the working of model training process. So we are importing iris data set from SNS Seabird library, and it will extract data set in the form of data frame. And if you want to see first, if you want to check first 5 columns of what we have in our data set, then you can use dot head method. So it will show you first 5 columns and rows of our data set. So in this data set, we have 5 columns. Our target, or we can say dependent variable, is species, and 4 features. So the problem we are going to solve is predict the category of flower based on given features. So we are predicting flower types and what is sepal and petal. So you can see this is petal, and this is width of the petal, length of the petal, and sepal. This is the length of the sepal and width of the sepal. Or based on these 4 features, we are predicting the category of flower. Species dot unique. So this is another way. If you want to check how many unique value in particular column you have, you can use dot unique method by giving column name in the data frame, and it will show you all unique value. And these are 3 target variable values, or we can say we have 3 classes in this problem. So for this problem, I will remove 1 class and I will make it binary classification problem. And in the next example, I will show you how you can solve multi-class classification problem. So let's say if we have any null value, we are dropping 1 category of the flower, and now we have only 2 category in the flower in the target variable. In this case, same like we are encoding our categorical data into numerical data, that will increase the working of model training. So now it converted our target variable value as 0, 0, 0 and 1, 1, 1. So now we have binary classification problem. We are splitting dependent and independent variable. Data frame dot ilog is an other pandas method that we can use to extract any number of features, or we can say rows and columns. So it is same like in C++, giving index of the array. So we are giving rows, number of rows, comma, number of column, and comma means we want to extract all the rows, and -1 means we are ignoring only last one, the species attribute, and it will extract all the features by ignoring just last column, that is species, and the last column we will store in the variable of y. So this is our feature variable x, and this is our y target variable. So let's split our data set into 2 half, training data set and testing data set. In which we are considering 25% testing set and 75% as training data set. Now we are creating logistic regression model and giving X train and Y train to the model to start the training process. And we will give X test data set to perform prediction from the model, or we can say to check the performance of our model. So the model has been trained. So the next step, if we want to check the performance of our model, then we can use accuracy score method and giving Y predict and Y test, and it will give us score, or we can say accuracy. The accuracy is 92%. And classification report method will give you a complete overview. For example, it will give you precision, recall, F1 score, support, accuracy, and so on. Precision is nothing but true false divided by true false plus false. Precision will give you true false as a true positive divided by true positive plus true false, and recall will give you true positive divided by true positive plus negative false negative. And F1 score is nothing, it is but just a trade-off between precision and recall, and accuracy, you already know what accuracy is. So let's draw the confusion matrix of our model. So we are using C-burn library to draw the confusion matrix. We are drawing heat map, giving X label, Y label, and this is the confusion matrix of our trained model. So 13 is denoting true positive, 1 is denoting false positive, and so on. So its mean model true positive mean model predicted correctly, and false positive mean model predicted wrong value. So in the last example, now we are considering multi-class classification problem, in which we have multiple independent variable and one dependent variable, but we have more than one classes. So we are loading a digits dataset from sklearn library. So digit dataset is related to handwritten images, and the problem that we are going to solve is predicting what the digit we have in image based on giving images as features, and the model will predict whether we have 1 or 0 from 1 to 9, what the value is we have in our image. So these are images 8 by 8 size. We are checking whatever attributes we have in our dataset, digits, and we are getting one data. This is how the image dataset looks like in RGB form. We are creating linear regression algorithm. Logistic regression algorithm, and we are importing train test split, dividing dataset into testing and training, giving training dataset to the model, and checking the performance of our model by giving X test and Y test to the score method, and the accuracy is 96%. And if we want to perform any prediction, then just use model.predict and .digit, and then give the list of all the features. So in this case, we are giving only 5 features, and the model is predicting 0, 1, 3, 4. And if you want to draw confusion matrix, then you can draw confusion matrix by confusion matrix, but it is not good in visualization. Then we can draw a graph of confusion matrix with the help of C-burn libraries. So we are passing SM, that is from previous. SM is a variable that contains the confusion matrix, and we are giving that confusion matrix to C-burn library to draw the confusion matrix, and this is how the confusion matrix will look like. So if you want to read it, 9 mean how many times model predicted correctly actual 9, but model predicted 1 time 7, 1 time 8, and 35 time 9. And if we talk about 8, model predicted 1 time 1 and 23 time 8. So this is all about 2-day implementation work. If you have any question, you may ask, please.
Okay, if any student, so thank you very much, Mr. Kareem and Dr. Moazzam, to deliver the trail lecture. So any student, if you have any questions, so please ask. Okay, you can also speak and you can also send your question on the chat as well. Okay, so the question, okay, so Mr. Kalim, you can also see the Zoom chat as well, the questions are coming.
Confusion matrix will tell us about the model performance, like how many times model predicted correctly and how many times model gave us wrong prediction. So we can check the comparison of actual value and the predicted value. Any other question?
Okay, so one question is asking, can you share this Jupyter notebook?
Yes, sure, I will share it.
Okay, please. Okay, students, I will share with you. Okay, the next question, any resource that summarize all algo pros and cons when we will use which algorithm?
It depends on the problem what we are going to solve. For example, if your problem is to predict a selling price or cost related thing, yeah, or we can say continuous value, then you can go with linear regression. Or if your problem is to perform a categorical outcome, then you can use decision tree or logistic regression. So it's all dependent on the problem what you are trying to solve. Model is same. The working of the logistic algorithm is same as the linear. The difference is it will give you only categorical value. And how it is giving you categorical value? It is using sigmoid function. Sigmoid function is a function that take any outcome in the continuous value and will convert it into the form of 0 or 1. What type of features you have to use, it totally depends on your requirement and on your problem. You can consider any number of features as according to your need. Cost function is related to cost function will give you the error, whatever the error is between the actual prediction and the, whatever the model predicted and the actual, and gradient descent is used to minimize that error. Any other question? Okay, thank you.
Thank you so much, Klim.
Okay, so please,
Umair, please, over to you.
please, sir, you can, please.
I'm fine. I just want to say thanks to Klim and other students. And next over to you. You might share the resources with other students and hope we will have our next lecture on unsupervised machine learning techniques.
Yes.
So,
Okay, so thank you very much, all of you, to join the second class. And as I mentioned in the group that basically the students who are attending the lecture only, they receive the recording and the lectures. And okay, so at the last, please open your webcam, so we will basically take a picture. So then we will close our meeting. So Mr. Kalim, you can also unshare your screen, so then we will take a picture. Okay, so thank you very much. I will take a picture now. So please smile. Okay, so thank you very much, all of you, to join the today lecture. So I think it's a very interesting lecture. Thank you very much, Dr. Mozem and Mr. Khalil.
Most welcome. Thank you so much,
Thank you.
and hope inshallah to see you in next lecture. God bless
Thank
you.
you very much. Okay, okay.
Thank you.
Okay, Allah
Allah
Hafiz. Thank you very
Hafiz. Allah
much.
Hafiz.
Assalamu alaikum, Munir.